All right, let's talk about something that sounds straight out of science fiction, but is way closer than you might think. We all know roads are for driving on, right? But what if they could do more? What if the road itself could power your entire journey?
I mean, really, just stop and think about that for a second. No more range anxiety. No more planning your entire trip around where you can find a charging stop. What if the very act of driving your electric car was the thing that kept it charged? That's the wild, revolutionary idea we're diving into today.
And to really get why this is such a game changer, you have to look at where we are now versus where we could be. On one hand, you've got today's EVs. They're defined by these huge, heavy batteries, which means limited range, a total dependence on charging stations, and ironically, it actually makes them less energy efficient. But the vision? The dream? It's a world where EVs have tiny, lightweight batteries, practically unlimited range, and are way more efficient because they're refueling on the go.
So, what's the big roadblock here? Well, it's literally the EV's heavy burden, that battery.
Look, it all comes down to basic physics. The heavier something is, the more energy it takes to get it moving. So, to get more range out of an EV today, we have to add more battery. But that adds more weight, which means the car needs more energy to move. You see the problem? It's this vicious cycle that just makes the whole system less efficient than it could be.
So how in the world do we break out of that cycle? Well, it starts with a pretty clever and surprisingly practical idea for city driving. What if we could get a little power boost at every red light?
The tech that makes this whole thing possible is called induction charging, and you've probably already used it. If you've ever just dropped your smartphone on a wireless charging pad, you get the gist of this. It's all about sending power through the air using magnetic fields. No plugs, no physical contact, just seamless energy transfer.
And check out how simple this could actually work. Your EV rolls up to a red light. An RFID sensor in the road says, hey, an EV is here, and boom, a charging pad buried in the asphalt wakes up. For that 30, maybe 60 seconds you're just sitting there anyway, your car is getting a quick top-up. It's a really elegant solution.
Okay, so that's a fantastic fix for all that stop-and-go city traffic. But it kind of begs the obvious question, right? What happens when you leave the city limits and hit the open freeway where, there aren't any red lights?
And that's where we get to level 2, charging on the move. This is where the freeway itself basically becomes your fuel tank.
Now, the real genius here is how this completely flips our original problem on its head. Imagine charging coils built right into the fast lane. Your car is just soaking up power while you're cruising at highway speeds. And that means the battery in the car doesn't have to be some massive, heavy beast anymore. It just needs to be a small, lightweight pack with enough juice to get you from the freeway exit to your driveway.
But why even stop there? If you can power a vehicle from the road, why does the vehicle even need to be touching the road at all? Let's take this concept and just push it to its ultimate mind-bending conclusion.
Welcome to level 3, folks, the road that propels. This isn't just about charging anymore. This is the ultimate vision for completely frictionless travel.
This quote from the source material just nails it. We're talking about vehicles that don't roll, they float. They would be suspended just above the surface of the freeway, totally eliminating the drag and friction you get from tires on asphalt.
And that is the absolute core of it. No wheels, no friction, just the powerful, invisible force of magnets doing all the heavy lifting. Literally, and pushing the car forward. We're talking full-on maglev technology, but for your car.
So how would this even work? Well, researchers are looking at a couple of different paths. One idea is a lot like those high-speed maglev trains you see, using powerful electromagnets in both the car and the road to lift and propel it. Another really cool idea involves putting spinning magnets inside the wheels, which would cause the car to levitate over a special aluminum roadway. Two different approaches to the exact same amazing, frictionless future.
So let's just recap the incredible journey we've been on. We started with a fundamental problem. Heavy, inefficient batteries are holding EVs back. The first step, level 1, gave us a clever fix for cities with stoplight charging. Level 2 took it to the highway with in-motion charging. And it all culminates in this ultimate level 3 vision. Roads that don't just charge our cars, but actually lift and propel them.
It's just an amazing progression from a simple, practical problem to a full-blown sci-fi solution. And it leaves you with this one last, really exciting thought. If we can build power and even propulsion into our roads, what else could we build into them? What other intelligence could we embed in the very ground our vehicles travel over? The possibilities are pretty mind-boggling.